Hello fellow problem solvers. So today we're going to be doing a problem from the 2008 IMO Shortlist, problem number G8. I suggest you try this problem out for a minimum of 20 minutes, ideally an hour, but not more than 2.5 hours. If on the other hand you'd like to go along with us, I suggest you give it a go for the next 15 minutes. And now, without further ado, let's begin. So, what the problem says is prove that AC is perpendicular to BD if and only if there exists a point P such that this whole thing holds. So now, what's the first step here? Well, for me, the first step is, let me see, this would be easier, I believe, to assume this and try to prove that, rather than the converse. But the first step for me is, let me see what kinds of things does this point P satisfy. So let's draw actually another diagram. And now we have A, B, C, D. Let's see what are these angle conditions. So PAB, well, that's this angle right here. PAB plus PDC, and that's this angle right here. The sum of them is 90. So if this is X, this is 90 minus X. And I think, yes, it seems like everything else is just, now this angle plus this angle. Okay, so now it's, I believe cyclic would be the term here. And with this in mind, here I'm going to ask you a simple question. Knowing that your condition is this plus this is 90, how would you use that condition? And also, you have this angle plus this angle is 90, like 90 minus y and y. How would you use these conditions? And I invite you actually here to pause for, let's say, 10 to 15 minutes and put some ideas as to how you would use this condition for P. And now, I don't know about you, but for me this is slowly becoming a pattern as I'm making these videos. And it's like, if I want to sum up these two angles. So let me take the intersection of these circles. Okay, this is like a bad intersection. But let's call this, so this is P, call this point Q. And now what do I have? I have this angle here, PQC, is going to be 90 plus X. And this angle, PQB, is going to be 180 minus X, which means the angle BQC is going to be 90. And now, doesn't that seem nice, right? And also, if I did a similar thing intersecting these two circles, again, I'm doing this horribly, but call this other point, say, R, I'm also going to get, I believe that, yeah, these angles are 90, ARB and DRC. And now with this, and also mind you, I would get the same thing on the other side, because I can, now this is the cool thing, with this angle condition that I would also get DQA is 90. So this is how I can think about using this sort of thing and can give me an idea as to what I need to do to construct P. And now with this sort of intuition, I invite you, with this idea actually, I invite you to pause for another 10 to 20 minutes and try to push the problem further. See if you can, now that you have P and these 2 points, could you maybe construct this intersection? Could you make it? Could you add a point? What is this point of intersection? If it's 90, what does that have to do with these other points here? I invite you to take the time and pause now. And here's where a good diagram comes in handy. So let's assume, and let's do the contrary now. Let's go solve the problem backwards. This is what we can do in geometry. So solving it backwards, call this point E, the point of intersection. What do you have for Q? See, so you have for Q that this angle right here is 90, and this angle right here is 90. And now with that, can you see what holds true for E, this point of intersection of diagonals? Well, E is the second intersection of these 2 circles now. So here will be the second intersection of these 2 circles. And now my challenge to you is to pause for 10 to 20 minutes and see what happens when you intersect the circles around BQC and AQC. What does that give you? What does this call this point E? What do you have for point E, taking into account all the conditions that you have for the problem? I invite you to pause now, and here's the next step. So once we do these intersections of P and then we construct this point E, we have that DEA and BEC are both 90. And now we only need to prove that DEC or AEB is 90. The other one follows, like it's symmetric, mind you, with regards to this angle and this angle. And now how are we going to do that? Well, the question is, how do we get the angle AEB? Well, I invite you actually to pause for 5 minutes and figure out how you get this angle. And here's how you do it. So the first thing you do is you write this angle down in terms of Q. And you forget about point E, because now you're simplifying your picture. You know that this angle is equal to QDA plus QCB. And now the question for you is, actually maybe draw another diagram if you want. Here you go. And ask yourself, how are you going to get QDA plus, so let me see this like this, and then, okay, so here's Q, here's P. And now how do you get the sum of the angles? QDA plus the angle QCB. Knowing that the way you constructed Q was that it's the intersection of these two circumcircles. And you know what you have? The thing you do have is P and every one of these points. So how do you do this? Well, the answer is, and you get it by having QDA plus QCB. You just take it all now in terms of P and Q. Okay, and you do it by looking at QDA is actually PDA minus PDQ. And then you have PCB plus PCQ. And now these two will cancel out. And you're left with that this angle is actually PDA plus PCB, which is what? By the problem statement, that's 90. And you're done. So now this gives you that. The angle, what was it? AEB is 90 now because AEB and which one other? We had DQA, so AEB and DEA are both 90. This means E is on BC, and we can analogously also get, actually no, we get it analogously right away because BEC is also 90, so we have this is actually the intersection of diagonals, which are perpendicular because all these angles are 90. And now with this, I invite you pause for 15 minutes and ask yourself, how would you now assuming that you have that these perpendiculars are at 90, not perpendiculars, diagonals are at 90 in a quadrilateral, how would you get this point P? Pause for 15 minutes and do it now. Here's the solution. And the answer is it has to be the same way you got it before. Right? Because there's no other way. You need to intersect these two circles and then these two circles, and that's how you get P. And now the only thing you need to do is calculate that all the angles like P. I think what you need to do, so PAB plus the angle PDC, now that's going to be symmetric with the PBA plus PCD. I think that's where we have symmetry. We need to show that this is 90, and we need to show things that don't have symmetry, which is say PBC, so the angle PBC, plus the angle PAD. Yes, PAD. If we show that both of these are equal to 90, then we are done. And now how do you show this? Well, I invite you, if you haven't figured this out, I invite you to pause now and try to show this for the next 10 minutes. And here's the answer. And you do it in reverse, just like you have before. You just PAB plus PDC. You just reverse it. Now you're trying to get rid of P. And you get rid of it, da-da-da-da-da. Here it is for your own viewing pleasure. And similarly here, you just do the thing this is 90. So you can do the thing we did beforehand. And analogously, the thing holds for the other two sets of angles. And this finishes up our problem. I like this problem because it's a difficult problem, mind you. It's a G6 on a shortlist, and which means it's a difficult geometry problem. But it's one, two maybe big ideas. I think this is one very cool idea, these intersections, bam, how you get new points. Because you're thinking about, how do I take advantage of this condition? I have these two angles. They're not that nice. How do I add them? And there's many ways to do this. You can mind you, there's 100 ways to do it. You can construct a point somehow that this is 90, then this point is equal to this one. You can try to do many different things, But this, I believe, is like a very clean way that I've seen used before, and you use it here. And yeah, it's just a cool little trick to have up your sleeve. And this finishes up our problem, and as always, thanks for problem solving.